Did you want to talk about Voyager?
Yeah, now we can talk about the NASA. Whoever's on video can see my hoodie. The NASA missions.
You're so unique, Ray.
Okay, listen. I wore it just to show the people. I wore it to show the people that I have a NASA hoodie. Like that's all. That's all. Now
Very
you
nice.
know. Now you know. Anyways, so maybe one of the most profound missions. Remember, I'm not characterizing. One of the most profound missions that Mars has ever. I mean, not Mars. NASA has ever launched. Right, Voyager. The Voyager missions. The idea for them was to study the outer parts of our solar system, right? Because we could kind of see a lot of things happening around us, and like, you know, going to Mars, going to Venus. It wasn't easy, of course, but the trajectory to get there was a lot sooner. It was a lot faster. So people were like, okay, now let's try to explore the outer regions of our solar system. And that was basically the birth of the Voyager program. Now, originally, there were 3 Voyager spacecrafts planned, but as you might know, only 2 have been launched because the third one was apparently canceled and the extra parts and extra money had been put into Voyager 1 and 2. So they actually became even better, which is kind of interesting to think about, you know. So quick fact too. Now, one would think that Voyager 1, being named 1, would have launched before Voyager 2. However, Voyager 1 was released, or not, I keep saying released, it was launched 16 days after Voyager 2. Now you must be like, well, that's a little interesting because like it's called 1. Do remember, this is all the same program. The numbers are simply to identify what the mission was, what the primary goal was of that spacecraft, right? So Voyager 2 was simply looking at like Jupiter, it was looking at Saturn, it was looking at like the systems in general, but nothing, and it also saw Uranus and Neptune. However, Voyager 1's primary goal was to take a very close look at Titan, which is one of Saturn's moons, right? Now, why is this so important? Because Titan, as you guys might know, you know, like the icy planet that might have life. A lot of people were talking about that. So the idea is that people started to notice that the atmosphere of Titan, obviously after observation, was a little interesting. So they wanted to check it out a little more, and that was the birth, and that was the main reason of Voyager 1. So it was released later because it needed a better trajectory. Like sometimes you need call the interplanetary window. So you need that interplanetary window to launch, and then in that window, you're good to go. So those were the 2 very important missions in NASA.
And these 2 missions were launched. Like, no, you don't say missions are launched.
No, the spacecrafts were launched.
Yeah, the two spacecrafts were launched on the specific dates and times that they were because of some calculations that were done in the 1960s. So in the 60s, they were looking at the orbits of the inner and outer planets, and they saw that, hey, in a decade or so, there's going to be a very specific alignment of the outer gas giants that will create this, what's it called? Solar highway? No, not solar highway. Like the planetary highway, you know, for...
Like gravity, like to help, like in gravity assists? Like
like essentially that's what it's
again,
it's,
like it's all like
doing.
about the interplanetary window, right? Like the most optimal time to launch your spacecraft to get in a certain orbit. Because of the way the planets are, like it all depends on a very particular time. And obviously it's a pretty broad window. It's not like 5 seconds or something, but like depending on what you wish to achieve, you can calculate the size of the window. And usually it can be, you know, a few hours, a few days here and there. So
a few hours.
Because like it depends. Like for the ISS, for example, you have to get it like within, I think, like 10, 15 minutes or something.
Oh wow.
Again, I could be wrong, but it is a lot shorter is what I'm trying to say. But for stuff like interplanetary travel, you don't have to be on the dot, right? Is what I'm trying to say. Like you can be roughly here and there because it's much larger distances at stake.
And this window, this perfect time to send the Voyager and Voyager 1 and 2 only appears every 176 years.
Oh
And so
my.
that's why they
Wow.
actually started like working on the project and not rushing, but I'm saying like they calculated it in the 60s and they're like, okay, we should get these spacecrafts finished so that, once the window arrives, we don't miss it and we can actually take advantage of this opportunity.
Hmm. Yeah, it's like, and then that's why Voyager is such a profound mission, right? Because not only, because it's also one of, oh, we didn't talk about the biggest part about Voyager, the fact that Voyager 1 is the first spacecraft to achieve interstellar, right? Or interplanet,
Hmm.
yeah, interstellar, to receive to no, wait, it's not interstellar, it's still in the solar system.
No, Voyager 1 has left the
No,
solar
it's
system.
left the solar system, but it's like still in the.
It
It's not
still
an
counts.
interstellar medium. Sorry,
Yeah,
sorry.
it
I should
still
have changed. Is
counts.
it okay?
Yeah, interstellar.
Okay, so Voyager 1 is the first spacecraft to achieve this interstellar travel and right now it is still moving away from us. Right, it's moving away from
Hmm.
us quite fast, and it's basically not really sending any signals. It's just moving through space time.